Stars are hot bodies of glowing gas that start their life in nebula. Diameter range of stars are 450 times smaller to 1,500 times large than our Sun. Like diameter, every star's mass and temperature is also vary. Star's color describe its temperature. Hottest stars are blue and the coolest one are red. Stars are divided into two categories: small stars and massive one. Small stars having 7 stages of its evolutions. A nebula is a giant cloud of dust and gas. It is a region in which new stars begin to form. The dust and gases in a nebula are spread out, but gravity can slowly begin to pull together and make clumps of dust and gas. Clumps get bigger and bigger and their gravity gets stronger and stronger. Now it's begin to collapse by its own gravity. The collapse process make the element on its center. Element form into a hot ball. It is a protostar. It is too young for fusion process, and its temperature is not reached at that level, in which we call it a proper star. It will continue to accrete more matter and heat up until it reaches about 10 million degrees Kelvin.
Finally, it's reached at that level, in which we call it a star. Now nuclear fusion is begin, and hydrogen fuses to form helium. In this stage, star begin to release its energy and start shining. Our Sun is an example of the main sequence stage. A star like Sun spent 10 billion years in this stage. Means star spend its 90% life in this stage. Hydrogen is fully converted into helium form. Now fusion processes start again. But this time, helium fuses to form carbon. Due to this fusion, outer shell of stars expand, cool, and lose its shiny matter. Now it's become a red giant. Helium is runs out, and outer shell is drifted away from its core, as gaseous shell, and we call it planetary nebula.
Remaining core, that are 80% of the original stars now, turned into a white dwarf. In this condition, stars having no capability of fusion. But it's hot for providing light. That's why we can see it in a space.
Sometimes two white dwarfs are close. Due to gravitational force they collide and form a neutron star.
If there's no another white dwarf, then it's cool down and finally reach at the death point. Core is turned into ash, light is gone, and star is totally dead. Due to its black color, we call it black dwarf.
Now talking about second type, that are massive star. Massive stars are 3 times to 50 times massive than our Sun mass. Like small stars, they also having stages. In first 3 stages, till main sequence stage, everything is similar. Just massive stars' fusion speed is too much fast for this process. For example, if small stars taking billion years for fusion, but massive stars takes just few million years in that process.
After main sequence stage, massive star form into a blue supergiant. Hydrogen runs out, but there's no beginning of helium fusion.
Helium starts burning and expand its outer shell. Due to helium fusion, its color turn into red, and blue supergiant now become a red supergiant. Its core turn into iron element, and collapsing processes start. Collapsing produce explosion on its core.
We call it a supernova. Supernova is too bright. That's why it is visible in our Earth when it's happened.
Sometimes cores survive after explosion, and core size decide its further formation. If core size is in between 1.5 to 3 solar mass, then it form into a neutron star. But if its size is more than 3 solar mass, then it form into a black hole. Story is not ends here. If two neutron stars are collide, then they also make a black hole.
So this is the life of a star. Hope you liked this episode. Don't forget to subscribe. If you like this video, then hit like and comment on it. And click on the bell icon for next episode.